Okay, the next section deals with the fundamental theorem of calculus. There's actually two of them. This is the first one. We'll deal with the second one the next down the road. Couple of them. Two concepts in the book that we need to be familiar with. What the fundamental theorem of calculus is. And this is where we kind of a more practical use of integrals or antiderivatives. And it says that the function is continuous on a closed interval from a to b, and capital F is the antiderivative of the function of the interval from a to b. Then the integral from a to b, putting a on the bottom and b on top, of f of x dx is the integration of b minus the integration of a. Okay, so now we're limiting, instead of going with theoretical infinity and zeros and all that, we're going with actual figures. So those areas that we were finding before in restricted regions is now predictable using integration. Okay? Now the book also included some very important guidelines for using the fundamental theorem of calculus. First one says, provided you can find an antiderivative of f, you now have a way to evaluate a definite integral without having to use the limit of a sum. So we did all that work with sums and limits and all that, which were helpful in understanding where we got to this. But now we can use the fundamental theorem of calculus to get an exact figure right off the bat. The second one is when applying the fundamental theorem of calculus, the following notation is convenient. Alright, so let me show you the notation we're talking about here. So, if you have some kind of function, that you are going to be looking at, say, from A to B, then this is going to be equal to that function of B minus the function of A, and then when you simplify this, you're going to come up with a value for x, whatever that is, and we're using this notation to show that we are going to be going from A to B. So whatever numbers we have, we're going to be doing a subtraction of those two values, and the designation for doing that looks like this. Just a one-sided bracket. Okay, and then the last one, it is not necessary to include a constant of integration C in the antiderivative. And the reason for that, the reason why we don't use C here, you notice here that this is going to end up with plus C when you do the integration. This is going to end up with plus C in the integration. But since these two are subtracting, C minus C is 0, it drops out. So we don't have to deal with constants when we're coming up with definite intervals. Alright? So, we have some odd numbered problems that I want to show how to do, so to kind of give you some even footing on what we're going to be dealing with here. So on page 291, I'm going to start off with problem number 5. And in problem number 5, we're going to go from 0 to 1 in our integration of 2x dx. Alright, so we do the integration of this, and this is going to be, this is 1, so that means that we're going to put a square there, and then we're going to divide by that 2 right here. These, of course, cancel out, so this gives us x squared. So now we're going to be, and again, we don't worry about the c, because we're going to subtract the function of 1 minus the function of 0. So we put up there 1, 0 to show that that's exactly what we're going to be doing. So for this is going to become x squared, which is 1 squared, minus 0 squared, which is 0. So our answer is 1 for that. It's that simple. The only thing new about this is the fact that we are now limiting our discussion to definite beginnings and endings. Okay? Number 9. Number 9, the problem here is that our integration is going from -1 to 1 of t squared minus 2 dt. Okay? So, again, we're going to derive this, and we're going to split this into two parts. -1 to 1 of t squared minus -1 to 1 of 2. Alright, and so this is going to keep this up to the next higher exponent, which is 3. Then we're going to divide by 3 for that. Again, don't worry about the c. Minus, and this is x to the 0 power, so this becomes 2x to the first over 1. So this becomes, here I am using x. T's. Okay, so this gives us t cubed over 3 minus 2t. And now we're going to be using that from -1 to 1. So we start with the 1. That's going to be 1 cubed over 3 minus 2 times 1. That, all of it, is going to be subtracting with the same thing now with -1 plugged in. So it's -1 cubed over 3 minus 2 times -1. Well, this is going to be 1/3 minus 2 minus, and -1 to the third power is -1, so that's -1/3. And -2 times 1 is +2. So we do a quick little arithmetic here. We know this is going to be a negative. This is 6/3 here. So 1 minus 6 is 5, so -5/3 minus, and then -1/3 plus 2, this again is 6/3, and then you're going to add that, it gives you 5/3. So when you subtract two positive numbers, the same as adding a negative number, and this becomes -10/3 for your answer. Alright? Number 13. Number 13, we're going to look at the derivative from 1 to 2 of 3 over x squared minus 1 dx. So this is going to be the same as the derivative from 1 to 2 of 3 over x squared minus, or I should be putting dx effectively. They haven't been derived or integrated yet. So minus 1 times dx. And so this comes in, well, we need to rewrite this, so let's make that derivative from 1 to 3. And let's take the 3 on the outside, and let's make that x to the -2 power. And then minus 1 times the derivative of x, which is just going to be x. Okay? So now, the next thing we're going to do is we're going to divide this. We've already divided that over there. Now we're going to divide this right here. And again, I should have a dx right there. So this goes up to -1. So that means we're going to have 3 times 1 over, well, this is what it is, x to the -1 over negative 1 minus x. So this becomes then, the negative sign goes to the 3 here. This would be a negative 3. And then this becomes in the denominator as x to the positive 1. So negative 3 over x minus x is our final subtraction of the integrations there within the function. And now we're going to subtract the values that go with it from 1 to 2. So this becomes negative 3 over 2, because we start with the larger number first, the b. So negative 3 over 2 minus 2. And then we're going to subtract the a value being plugged in here. So that would be negative 3 over 1 minus 1. Okay, so we're going to do a quick little math here. This is going to give us, I'm going to change that to 4 halves, so I can add these together. That's a negative 4 halves, so this is negative 7 halves. Minus negative 3 over 1, well, gosh, that's negative 3. Minus 1, which is negative 4. So that means we change these signs to addition and positive, and our answer becomes 1/2. Okay? All right, let's take a look at number 17.